Hi, this is a quick video over the periodic table trends notes. So if you missed class, you'll be able to fill that in. Let's take a look. Okay, there was a fellow from Russia named Dmitry Mendeleev. He's called the father of the periodic table because he was the first one to arrange the elements into periods and rows that helped people understand how matter works and how the elements can form patterns. So then he used atomic mass, but later when people started learning more about atomic structure, they discovered protons and figured out that atomic number and the number of protons actually determines the elements. Moseley arranged the periodic table based on atomic number. So he did the periodic table in order of increasing atomic number, and that's what we're still using today. So then when you do this, you can get the elements to have a regular repeating periodic pattern that's based on properties, periodic pattern based on properties. So let's talk about those type of properties that are repeating. So first of all, things are grouped together based on the class of matter. We have metals, metalloids, and nonmetals. And then the atomic radius, things with a similar atomic radius are grouped together. The atomic radius decreases as you go across the rows, and the atomic radius is related to the number of electron energy levels that the atoms of different elements have. We call this the period. The rows on the periodic table are called periods. All right, the columns have a special name too. They're called groups, but some people call them families. So you need to learn the word groups and families, even though they mean the same thing, which is a column on the periodic table. The columns are arranged based on the number of valence electrons. The V is valence and E minus is electron because electrons are negatively charged. And the valence electrons are those electrons a lot of times in the outermost layer, but not always. These transition metals are the exception to that rule. But they are the ones that are involved with chemical bonds. All right. The metalloids are the elements, except for aluminum, that are along this stair step that you'll see drawn on a periodic table. The metalloids are there, and nonmetals are to the right of the metalloids. They're to the right of the stair step. Nonmetals all have things in common, like they are not shiny. They're not ductile or malleable. You can't bend them into shapes or hammer them into a shape or make a wire out of them. You can't, if you try to bend it, they just break. They're brittle, or they're a gas. They're a gas, but there's a wide range of types of things here, but all of them are not metal. They're not metallic. They're not shiny. They don't conduct electricity. They don't conduct heat well. They're non-metals. Even if you can get them to be solids, they don't behave like a metal. All right. Hydrogen is kind of a weirdo. It's a non-metal. Obviously, it's a gas. Doesn't conduct electricity well, even if you can get it to be a solid. But it's not over there with the other non-metals, and there's a reason for that. It's based on the valence electrons. All right, all of this blue right here are the metals. Metals have things in common, like they conduct electricity and heat very well. They're shiny, they're malleable, you can hammer on them, and they don't break, they just bend into a different shape. You can form them into wires. That's called ductility, or being ductile. Shiny and all that kind of stuff. Metals, you know what metals are. So that's all of these elements are metals. So they all have something in common. They're grouped together based on the arrangement of columns and rows. So the metalloids, what about them? Some of them are shiny looking, but then they don't conduct electricity, or they might conduct electricity, but it has to be heated to a certain temperature in order to conduct electricity. So they kind of have some properties like a metal and some properties like a non-metal. So they get their own group, own class, I should say, not to make confusion. They get their own class of matter called metalloids. All right. So properties of metals are they're shiny, malleable, ductile, high melting point, conduct energy, like electricity or conduct heat, that's energy. Most are solid at room temperature. And you can pause this to write all that down, of course. Non-metals are dull, brittle, and poor conductors. Metalloids are the green. You can write the word metalloid there. You can put a text box if you want. All right, and then we wanted to just make sure you understand that the rows have to do with the period. So period 1 has 1 electron energy level. Period 2 has 2 electron energy levels. Period 3 has 3 electron energy levels. And period 4 has 4, and so on, except that you can see we're going to run out of space for drawing circles. All right, so there's 18 family groups based on the number of valence electrons. The valence electrons determine that group, and they have similar chemical properties. Like everything in group 1 has the same kind of chemical properties. Everything in group 18 has the same kind of chemical properties. So sometimes we say, take 2, skip a few, and then you have more. So these transition metals, those are the ones in groups 3 through 10, I think it is, or I don't have a table here. But anyway, their valence electrons are weird. Like they can actually have valence electrons from the outermost level, and then some from the one inner level that are involved with chemical bonds and stuff. So they're unusual. You don't really worry about the reactivity of them and stuff like that in middle school. But when you get to more higher level chemistry, you get to deal with that. All right, this next part of your digital notebook is some more notes, but there's a different video that Miss Hallmark made, and I'll let her explain all that, and you can write it down too. And so that's going to be the end of this video.